Hello lecture. Our group consists of three members. I am Nguyễn Minh Hy, the second is member Nguyễn Minh Trung, and the last one is Lê Hồng Phong. Today, our group will present the midterm assignment. The topics we will cover is the review question and problem of chapter 13. Our presentation will include two parts, a review question and problem. First, I will talk about the review question. 14.1. What are the tasks that a processor must accomplish? A processor must carry out several fundamental tasks. A SQL program effectively include fetch instruction. The processor The processor retrieves an instruction from memory, reader, get, or main memory, interpret instruction. It decodes the fit instruction to determine the required action. Fit data. If the instruction require data, the processor reads it from memory or an IR module. Process data. This step involve, involve performing arithmetic or logical operation using the ORU automated and logic units. By data, the process is research is written back to memory or sent to an IR module. 14.2. What categories of data are commonly supported by your visible register? Your visible register accessible by machine language. Generally, we support the following category: general purpose register, versatile register used for a variety of functions, includes entering and data storage. Data register specifically hold data and are not used in address calculation. Address register used for memory addressing includes index register, stack pointers, and Simon register. Condition cost register. How status flashes by operation. Zero side query overflow and arrest implicitly by instructions. 14.2. Disable the register that are essential to instruction execution. For primary registers are essential. 1. Program counter PC holds the address of the next instruction for to fit to instruction register storage the currently executing instruction. 3. Memory address register constant the address in memory for a rest write operation. 4. Memory buffer register temporarily hold the data reached from our written to memory. 14.4. What a program started work? A program started work in a processor register that her connection codes and control information. Typical components include 1. Sign, 0 carry overflow, indicates results of arithmetic logical operation. 2. Equal flag, results of comparison operation. 3. Interrupt enable disable, control whether interrupt are processes. 4. Supervisor mode flag, deter- determine whether the processor is in user or supervisor mode. 14.5. Way to stack instruction people line, you line to cut the instruction cycle time in half, although dividing the cycle into feet and skill stack such as a potential doubling in space. It flows short due to 1. Unicore stack duration. Execution takes more time than fetching scaling impedancy. 2. Conditional branch. The fit stack must wait for execution to resolve the next address from prediction leads to what is fit and delays. 14.6. This briefly explain why to handle conditional branch instruction people line. 1. Multiple streams fit both possible instruction paths and discuss the wrong one. 2. Preferred branch targets. 3. Pre-log the target instruction into the buffers before evaluating the branch. Log buffers. Storage storage and instruction in a fast asset buffers, improving performance in Thailand for branch prediction. Goals whether a branch will be take and fit accordingly, correcting it wrong. 5. Delays branch reorgan reorganize instruction after a branch to execute regardless of the branch outcome, minimizing delays. 14.7. How a history based view for branch prediction. History based track past outcome the branch to predict this future behaviors using structural line. Uh, Using base prediction. Remember if the branch will last taken or not. 2-bit prediction. As histories to avoid changing prediction a single misprediction. Branch history table. Store recent result of branch pattern table. User a pattern from the BTH to index a table that provides more information. Prediction.
Hello everyone. I'm Trung, and I will talk about chapter 2, problem. Lesson, lesson 1, 40.1. A. If the last operation performed on the computer with an APIC work were an addition in a with the two operation where 001 001 00 and 000 1 what would be the value of the flowing flash carry zero overflow sing ever event parity half carry B repeat for the addition of magnitude to the complete and magnitude 3. Answer. Perform binary addition of the two operations and check the resulting flash basic on the result. Add the two binary number 001 001 0 what is 001 001 but result here. Say no carry out from the MSB carry flat 0. The result is not 0 0 flat 0. The result does not accept the maximum value for an AP number overflow flat 0. The MSB of the result is 0. String plus what is it? 0. The result had a fall with an even number. Even parity flat version 1. Say no carry from bit 3 to bit 4 during the administration. Half carry flat with 0. The value of the flat are carry 0, 0, 0, overflow 0, string 0, even parity 1, half carry 0. Lesson B. Converted minus 2 to complete by revision of the 2 is 0 0 0 0 1 0 invert the bit 1 1 1 1 1 0 1 add 1 1 1 1 1 0 binary representation of plus 3 is 0 0 0 0 1 1 add the two binary number and we have result here. The value of the flag are carry dot 1 0 power up 0 overflow power of 0 0 and sing eventually 0 half carry 1. 42 repeat from repeat problem 41 for the operation A to B where A contain 1100 1100 and B contain 0011 0011 A square operation A power up 1100 1100 mine 52 yes 52 B B power up 0 1 1 0 0 1 1 operation A to B so 103 meter A plus minus B in the two combination minus B 0 0 1 1 0 0 1 0 0 0 the result here. The value of the first A carry 1 0 0 overflow 0 string 1 everybody 1 half carry 1. Next 43 a microprocessor had a clock cycle of 0.125 minutes. A. What is the clock rate of this rotation? B. What is the rotation of a particular type of matching instruction consisting of 7 clock cycles? Answer. A. Clock rate formula clock rate Power up 1 um, divided by clock cycle time. Calculating clock rate result A G has it. B instruction duration instruction uh, 7 clock cycle formula duration clock cycle time calculation duration um, result from 0 A 7 9 7 yep 7 7 there. Question 44. Microprocessor protein diver and instruction capital paper after moving a string of bytes from one array of memory to another. The fetching and interlinear encoding of the instruction takes 10 clock cycle. Share after it took 50 clock cycle to the transfer is by the microprocessor is clocked at the rate of 10 GHz. A. Determine the length of the instruction cycle for a string of 33 by B. What is the worst case delay for acknowledging and interpreting if the instruction is non-mutable? C. Repeat part. B. Assuming the instruction can be interrupted at the beginning of it by transfer. And square given clock rate 10 Z clock cycle time 01.1 instruction fixed flood record um, power 10 cycles each by translates power 15 cycles string length 32 by instruction cycle length from 65 cycle fit fit flood record 10 cycle transfer um, 33 and 15 50 yeah you saw here time 40 40 490 at 40 49 and square B. Post K interrupt delay the interruption in a instruction cannot be interrupted until communication. Post K delay the full instruction time. The power of 49 and C was K interrupt delay interrupt the by interrupted at the start of it by transfer. Worst case interrupt occurs just after starting by transfer. Delay power up time for one by transfer 15 that's 0 to 1 1.5. Question 45. The inter 01 A0 AA consists of the bus interface unit BIU and an execution unit EO which form a two-stage pipeline. The BIU features instruction into 4 byte instruction which the BIU also processes arrays calculation feature present and write result in the memory as represented by the AU. If no such research and other outstanding and the word is free. The BRU feels any benefit in the introduction process when the EU completed execution of the inner integration is passed any result to the BRU. A. Suppose the tech performed by the BRU and EU take about our time by what factor the pipelining improves the performance of the A0AA, ignoring the effect of branch intersection. B. Repeat the calculation assuming that the EU take time as long as the BIU. Answer A. Time check by non-pipeline processing. Power up time taken by AU. Uh, Flux time taken by PIU. Power up to T. Time taken by pipeline processing. Power up CPI estimate. Time by AU. Time by PIU. Power up 1 to T. Power up T is CPA of the ideal CPU E1. Answer speed up, answer speed up, and 2 3 divided by T, ratio 2. B. Time taken by non-pipelining processor. Time taken by U. Plus time taken by BIU. Power up 2T plus T power up 3T. Time taken by biolinic rotation CPI dot match time by EU, time by BIU, power up 1 dot 3T, power up 2T as CPI and IVU speed E1. Answer speed up 3T divided by 2T 1.5. Question 46. Assume an A0AA is executing a program in which the probability of a program is 0.1. For simplicity, assuming that R in instruction to be 2 byte long. A. What fraction of the instruction first cycle is faster? B. Repeat if the instruction which is A by long. Answer A fraction of the first cycle faster 4 by which 4 by power up 2 instruction 2 by zoom. Observe with probability 0.1 discard 4 by. Faster by per instruction zoom 4 by wasted no zoom no by wasted expected wasted by power 0.1 dot 0.4 plus 0.1 0.9 and 0 result we have 0.4 byte fetched by each instruction power up 2 bytes president power up what's the bit by innovate to fit byte and power 0.4 divided by 2 0.2. B. Precision of the feedback cytolet velocity A by which uh, which is A by um, power for interpretations zoom discard A by uh, Waster by per instruction expected Waster by uh, power 10.1 HA plus 0.9 0. We have the result 0.8 bytes which by 2 byte per instruction fraction 0.8 in divided by 2 um, power up 0.4. The question 40, 47. Consider the timing diagram of the figure 40, 10. Assume, that the J only a two-stage pipeline. Pick execute, execute breadcrumb the diagram to show how many times you need you now needed for instruction. As where we have a table instruction 1, 2, 3, 4, 5. We have instruction 1, 2, 3, 4, and the one uh, we have the fifth and 2 we have the execute instruction 2 2 we have fifth and 3 we have execute and instruction 3 um, the 4 we have fifth but and the 5 with 8 um, 48 a similar pipeline with 4 stage fit instruction uh, F is decode instruction and calculator at a rate DA fit operation FO and SQ as is the rest diagram similar to figure 49 4010 for sequence of the 7 instruction in with the third instruction is brain data attacking and in with journal data defense detection. As well we have a table here with time increasing with time 1 2 3 4 5 6 7 8 9 10 brain penalty in 1 to 2 to 3 4 5 6 and 50 50 and we have 1 we have FA FE 2 we have DA 3 we have FO and 4 we have FE in 2 we have 2 and FA FE and 3 we have DA for the FO and 5 FE in the 3 we have 3 FE 4 DA 5 FO and 6 FE in 2004 we have F8 4 and 5 DA and 6 FO in instruction 5 we have 5A and 6 DA in instruction 6 we have 6 HFA and in 250 we have 7 A 9 10 FE DA FO and S. Question 49. Pipelite processor had a clock rate of 5G and execute a program within 5 milliseconds instructions. The pipeline has four stages and instructions. It was at the rate of the 2 per clock cycle. Ignore penalties due to bad brand in instructions and out of sequence execution. A. What is the speed up of object processor for program compared to a non-multiply processor, making the same assumption due in section 44. B. What is the throughput in MIPS of the pipeline processor? Elsewhere, we have A. No dot of instructions and um, power 1.5 million, 1 million power um, 106. No dot of stay in a pipeline K power 5 instructions rate per clock cycle um, power 1 tour um, power 1 speed how speed we have nk and t divided by uh, k um, k plus n n my 1 uh, speed and 1.5 and 106 1 divided by 1 plus 1.5 and 1 106 and my 1 we have speed dot 1 power 1 and B. No of insufficient power 1.5 million MIPS power IC uh, divided by 2 T is 106 T power and K power 1.5 and 5 T power 7 dot 5 and IPS 1.5 106 and divided by 7.5 and 106 uh, MIPS power uh, 0.2.
So my name is Phong, and I will continue our presentation about the solving questions from 14.10 to 14.17. So a non-pipeline processor had a clock rate of 10 and an average CPI of 5. An upgrade to processor introduced a four-stage pipeline. However, due to internal pipeline delays such as large delays, the clock rate of new processor had to be reduced to 9 GHz. So we have A and B. So the question given us the non-pipeline processors is clue clock
Uh-huh.
rates, CPI introduction latencies, and pipeline processor include for pipeline
Ủa,
stage
dài.
the clock rate, introduction latency, and throughput.
15.
So the
Học đi từ
we have
từ.
the speed up is defined as this methods, so that assume that the program has five instructions, number five execute time, and pipeline execute time for large and we approximate pipeline execution time is n time 0.111. The speakup is equal 0.5 n divided by 0.111 and equal 4.5. About P, the throughput in I MIPS of the parallel processor throughput equal the instruction per second. Sync pipeline issue one instruction per one clock cycle. That means clock rate is equal 9 GHz equal the 9 times 10 powered by 9 instruction per second and convert to MIPS is 9 times 10 times 3 equal 9,000 MPIS. 14.11 consider to an instruction sequence of LAN and that is streaming through the instruction pipeline. Let's BP the possibility of encouraging a conditional or unconditional brand introduction and let the key be the probability that in execution of brand introduction I cause a jump to a non-consecutive address. Assume that each jump is a jump require the pipeline to be clear, destroying or ongoing destruction processing when I emerge from the last stage. Revise equation 40.1 and 40.2 to take these probability into account. So the question given us some like n is the number of instruction in the program and p, q, k, and t. So the answer of question is for original equation of 40.1 is non-pi line executing time. There is the t non-pi. It is methods no chain needed, but the pipeline plus don't apply here. For the 14.2, the ideal pipeline execution times, we have the method here. This assume a perfectly balanced pipeline with no store or hassles. The equation 40.2 revised with the brand plus penalties at the 3t pi. 14.12. One limitation of the multiple stream approach to dealing with the branch in the pipeline that additional branch will be encouraged before the first branch is resolved. So get to additional limitation of dropout. So I have the two additional limitations. First one is
Tin nóng à?
excessive hardware complexity and cost. Maintaining multiple instruction streams in parallel require duplicate or highly complex
Em,
hardware resources
em
like
em.
the multiple program counters or the multiple set of resistor or resistor tracking, separate buffer and keys for each team. This makes the design more expensive, power hungry, or harder to scale, especially as more branches are encouraged. Number
Chị biết.
two is waste computation and poor efficiencies. If only one pattern to be correct, then all computation from the incorrect path must be discarded. This leads to the waste recycle, increased energy consumption, reduce overall instruction throughput as a branching increase the percentage of useful computation drops dramatically, especially if spectacular execution is stiff. The 14-point testing, consider to the state diagram of figure 14.28. Describe the behavior of each compare this with the brand prediction state diagram in the section 14.4, discussing the relative merits of the each of its three approach to the brand prediction. So
Dạ rồi.
describe the behavior of stick of its state diagram in figure 14.28. We have the one bit brand partition single bit state machines. We have two state predict taken and uh, credit not taken. The behavior if a brand is mispredict, the state flip from taken to not taken or vice versa.
Hello.
The simple predictor is effective when branches behave predictably but perform poorly in case with alternative branch. And the second one is two big brand predictions. We have four stakes: the strongly taken, the weakly taken, weakly not taken, and strongly not taken. And the behavior is required to make prediction before changing the direction. We have avoid make prediction in loop or branches with occasional behavior change.
Vậy á.
This is more accurate than the one-bit prediction, but it reduces the sensitive to single bit prediction. And this is the table of the comparison of the three approaches. We have the state diagram, the adaptive branch behavior, the currency, the halfway cost, and the usage of scenario. 14.14.
Không.
In the case A,
Dạ.
the questions given us the A0 and A1. D1 is 255 in decimal, and the memory from 4000 to 6000 is filled with the value for 8. Analyzes the average comparison is 4 8 versus 4 8 there are equals. The zero flag is these equal ones does not discriminate D1 and notch branch. The loop will end after the first iteration. We have the result is lookout is 1 and A0, A1 and D1. D1 unchanged. And in the case B, the question given us the memory from 4000 to 4FEE is filled with 40, and the memory from 5000 to 6000 is filled for 8. Analysis it comparison is a lot of zeros versus a lot of eights, always not equal z equal 0. D, B, and E is taken every time, and the D1 is decremented. D1 start at 255, loop continue until the D1 is equal -1. That means 256 interactions. After the 256 interaction, we have the A0 equal this values, and the A1 it is, and the D1 it is -1. 14.15. Redraw the figure 14.19c, assuming that the conditional brand is not taken, like this picture. So original stake in figure 14.19c is a standard to big dust counter for the dynamic brand prediction that the strongly taken, weakly taken, weakly not taken, strongly not taken, which transition based on whether the actual outcome of the branch is taken or not taken. And the state transition from one not taken outcome if the branch is not taken, the transition go as this follows.
Chọn kỳ vậy đem chứ đó.
And this is the table I
Kỳ vậy đem chứ đó.
draw with this question. About
Tiếp càng
14.16,
ấy.
the table
Rõ.
the table 14.5
Anh
summary
lên kia đi
the
không?
statistic from the MACD 84 concerning the branch behavior, and with
Dùng
the
ngưng.
exception of type 1 branch behavior, there's no noticeable difference among the application class. So we have to
Dùng
repeat
định
the
nữa.
commercial and the system environment. The answers from the table 14.5, we have the branch behavior type 1 occurs 72.5% of all branches, and the scientific conditional when the target went to the target equal 43.2 percentage, and the brand
Dùng
type
ngập.
2 goes to the target of 91%. And brand type 3 always go to the target 100%. And about the science environments, we have the total of 57.41%. About the commercial environments is 49.82%, and the system environments is 50.76%. And as it is the answer, but 14.70, in this figure, the box are labeled to refer to the set of the register used to hold the temporary result. Complete the box block diagram that show at the top level at the structure of the pipelines. This is the pictures. To complete the block diagram showing the pipeline structure for flowing point addition of subtraction, we use the four pipeline state mentioned. The first one is to compare the exponent, choose the exponent and align the significance, and subtract the significance, normalize the result. The diagram can be split into the two parallel thread, like one for the exponent and one for significant. It's feeding into resistor R at the each state to hold intermediately result. So this is the table of it. We have four states. Compares opponent, choose the ESP and align signs, act as subtract signs, and normalize the result. And the description of the register is a one store result of exponent comparison and select a exponent. R2 is store align significant. R3 is store result of significant operation like add or subtract. F4 is store final normalized result. And that is information about our presentation, and thank you for listening.